Okay, so we are continuing with the network programming lab. So you already have done inter-process communication, implemented inter-process communication mechanisms using uh, say pipes, shared memory, message queue, such mechanisms. So now the new cycle is for again inter-process communication, uh, but over a network. Okay, in the case of IPC mechanisms, which you have already done, say for example, if it is fork or pipe or message queues, you're assuming that both the processes uh, between which you are trying to communicate, both of them reside on the same machine. Okay, but that is not really necessary, right? The processes can reside on different machines. Say, for example, a typical example is of the concept of a web server, right? So, what is a web server? Web server, we can just visualize it like this. Web server is uh, a machine, as well as you can think of it as a software which runs on the machine and whose purpose is to serve web pages to all those clients who request it. Okay, so you have this is our web server and web server. Okay, this is our web server, and we know our website, say ctc.ac.in, is residing on this. Website is residing means all our HTML pages are in a folder inside this machine. Okay, and I want to access ctc.ac.in. This is my laptop, and I'm making a request to this machine through a browser. Browser is the client. Okay, browser is the client. So I'm making a request. So again, browser is a process. Web server is also a process. So here browser is trying to communicate to the web server, sending a request, and the web server will check whether the page I have requested is there on the hard disk, and it will return the web page, which will be displayed by the browser. So here basically you have two processes which are communicating over a network. Now how does this communication happen? And can I write programs to actually do such sort of communication? So that is what this cycle of programs is about. So first two are the basic concepts. If you learn these two, then you can do any sort of client server sort of communication using this. Okay, so the first program is implement client server communication using socket programming with TCP protocol, and the next one is UDP protocol. And this is the major two protocols used over the internet for any sort of communication. So once you know how the TCP and UDP protocols can be used to communicate between two processes over a network, then after that you can actually implement any sort of application. That is, you can implement a chat server. Okay, chat server means you will have uh, a chat server means you have a server program residing on a machine, and you have clients who connect to these servers so that they can communicate with each other. Multiple clients like this. Okay. Similarly, a concurrent time server. Time server means you are communicating with that server in order to get the correct value of time. Okay, maybe our machines are syncing with our ISPs to get the time, something like that. Okay, so we have one server which has a time server. Time server is basically a program which will get the time from this machine, and then when another client requests for the time, it sends it back. That is all it does. And then you have the SMTP, Symbol Mail Transfer Protocol. It is basically uh, it runs on mail servers. Okay, you will have many mail servers in the internet, and this SMTP is actually used for transferring or relaying your mail to the next server. Okay, that is what happens in SMTP server. And finally, a concurrent file server. Okay, file server means you will have a machine with a file server program running, and it will have several files. That is, say in an organization, you want to have all your files securely stored on a single server to ensure that it does not crash, or it is secure from access from what unauthorized people and so on. So you have a file server. It has a server program running, and it has all the files in it, and you can actually log in using your credentials, request for a file and get it. Okay, such sort of a mechanism. Again, concurrent means you have any number of clients or more than one client accessing the system at a time. Okay, so this is what we want. This sort of communication is what we want to implement. Okay, so here the basic idea is communication is between processes on different machines over the network, and it is not. So earlier what we said is in the process communication, what you did was all the processes are residing on the same machine. Okay, okay. So you already are studying computer network, so you have a basic idea about what a network is, right? So network is basically a set of computers which are connected to each other, so that you can do resource sharing, and you can do say you can host a web server or a file server, and you can get information. All those things can be done. So when you talk about uh, a network means every machine has to be uniquely identified. Okay, every machine has to be uniquely identified. Okay, so now what we said is, okay, so what we said is we have two machines which are connected over some medium, wired or wireless or whatever, and you have one process called a web server, which we'll forget that. Web server which resides here, and we have a web browser which resides here, and these are two processes, and we need these two to communicate with each other, right? So how does that happen? Now, in order for communication between to understand that, okay, to understand the communication over a network between two processes which resides on two machines, we have to understand about the TCP/IP stack. Okay, you must be familiar with the TCP/IP protocol stack. TCP/IP. Okay, it's protocol stack. Okay. Now, in networks, you must have come across the OSI layers. OSI layers is basically a theoretical a set of layers. You start from physical layer, detailing layer, network layer, transport layer, presentation layer, session layer, application layer, something like that, right? You have a set of layers which was defined by uh, what ITU or ISO, whoever. Okay, they have defined a set of layers, but in actual applications or in actual machines, uh, we know the TCP/IP protocol is the most commonly used, the internet protocols. That is why it is called the internet, right? So the internet protocols, so the TCP/IP protocols is the most prevalent set of protocols which are used. It's the de facto standard, right? So TCP/IP protocol stack only has a lesser number of layers, and that is what is shown here. Okay, that is for each of the machines, it will have all these layers residing in it. Okay, so first of all, we'll talk about different layers. So here we have the physical layer, right? In physical layer, you must know that it is a physical layer, and data transmission takes place in the form of bits. And the physical layer, you can have the Ethernet cables which are used to connect machines together, or you can have fiber communication or satellite communication. Different types of mechanisms can be used for communication at the physical layer, and transmission of data happens as bits, right? In the next higher layer is a data link layer. Data link layer, you talk about frames. So any data which was in terms of bit streams here, you have packed up into a frame, and you have frame header and footer also in order to give the address of the machine to which you are sending and so on. Okay. on the layer above is called the network layer. This is where the IP part of the TCP/IP part comes. IP is Internet Protocol and it is used for network communication, or it is used to identify machines. So it is at this layer that we identify machines using an IP address. Okay, and then above it is a transport layer where you have the different protocols, and finally above that you have the application layer. So application layer is where the actual applications, or the web server, the web browser, the file server, okay, the client, file client, whatever uh, happens. Okay, and in each of our machines, in each of our desktop machines or laptop machines, we have all these layers in present as part of the networking software, or which might be part of the operating system itself. Okay, so when an application actually wants to communicate with another application, what happens is you can actually in the application program, if you are going to write an application program, you can make use of system calls in order to actually access these lower level layers. Okay, so here you if you want to communicate with this, you make a system call to actually set up a connection, and the system call actually goes to since we are at the application layer, system call goes to the next layer, the transport layer, and finally, or if you're sending data, it is gets transferred like this. And finally, at each layer, the headers are added, and at the data link layer, what happens is further on, what we do is it transmits in terms of bits, right? And then here the reverse process happens. You are removing the different headers, and finally you get the data, and the data comes to the application. Okay, so this is the overall picture of how the transmission happens. So basically, from the programmer's point of view, what we have to understand is, if you're going to build an application which needs to communicate, we need to know all the system calls associated with setting up and transmitting data. That is all we need to know. And so it is that which we will be looking at now. Okay, what is the IP layer? It identifies a device using a 32-bit IP address. Now, this 32-bit IP address is actually a logical address, which we need to understand. Okay, 32-bit IP address, actual physical address, is actually a 48-bit address called, I don't know whether you're familiar with it. It is a 48-bit address called MAC address. Okay, and in every machine, in every desktop or laptop machine, you will have what is known as an NIC card. Okay, network interface card. And since we generally use Ethernet, it is Ethernet card. Okay, and you have what is known as an RJ45 connector, RJ45 connector, which can be used to uh, connect your, that is connect your port here. RJ45 can be inserted here, and that is how you plug in this into the network. Okay, just get familiar with these terms. That is all I meant. Okay, now okay, TCP UDP layer identifies a process with which communication takes place using port numbers. Okay, we didn't mention this. So IP address. So in a network, we know that our machines are connected to the network in order to share resources, or share information and so on. And in a network, uh, the IP address, 32-bit IP address, is a logical address which is used to identify every machine. Okay, and we said, so in a network we can identify a machine using an IP address. Now within the machine you can have multiple number of processes running. Okay, multiple number of processes. We might have a web server or a file server or a client, or many processes might be there inside a single machine. Now how do you identify? That is, if you have a packet, like we said, we are sending packets this way, and the packets, this frame comes here, and then how does the system know that given a frame like this, that is, you have a packet, at this level, network level, it's called a packet, right? Okay, if the packet comes here, and if it is, and you remove the packet header, and then the remaining data part you send to the higher layer. Okay, and how do you know which process has to get this data? Because you have multiple processes running here. So that is identified using what is known as a port number. Okay, port number is generally a 16-bit number. So you can have a maximum of 2 raised to 16 number of ports, and that can be there for both UDP and TCP. Okay, so 2 raised to 16 plus 2 raised to 16 number of ports and number of applications can be run on that particular machine. Okay, so that is what is mentioned here. So TCP UDP layer identifies a process with which communication takes place using port numbers, and then finally this is the protocol itself. What sort of service? TCP means it is connection oriented. That is, you have to first have a handshake mechanism between the two entities. That is, a handshake mechanism has to happen between the two entities, and after that a connection is established. Okay, so after the connection is established, data is being transmitted through something like, you can imagine it like a pipe where you send data through it. Okay, that is in the case of TCP. But UDP is not connection oriented, it is connectionless, which means no connection like this is established. There is no handshaking mechanism. So whatever, you just send packets with the address, and it might reach the other end, it might not. That is what connectionless service is. Okay. Okay, so we talked about IP address, port number, etc. Okay, so now we have become familiar with the protocol stack and how to identify a machine, how to identify a process within the machine, and so on. Next, we will move on to how you can, from a programmer's point of view, what are the things we should know. Okay, so how can we, from a programmer, that is, if you are going to write a program, uh, uh, how do you do it? And that is where we have the concept of a socket. Okay, socket is actually an abstraction through which an application may send and receive data. So you can think of a socket in a machine. You can think of a socket in a machine as an endpoint. Okay, that is, there is an endpoint, a logical endpoint which is present inside the network, and this socket is actually uniquely identified by the IP address, protocol, and port number. So we have already mentioned what an IP address is. It is the logical address for a particular machine, and port number is to identify from among the different processes running. Each of the process might be attached to what is known as a port. So port number is used to uniquely identify the process, and finally, what is a protocol used? Generally, we can have TCP for connection oriented and UDP for connectionless. So based on that, you have two types of sockets also. This is actually sockets are an abstraction defined by the underlying operating system so that the programmers can use these facilities using system calls. Okay, so two categories of sockets are there. You have got stream sockets, which uses TCP. It provides reliable byte stream service, which means you have, like we earlier mentioned, you at two ends you have to create two sockets, and you have to create a connection, and once this connection is established, again all these are done through system calls, and then you can send and receive data in a byte script. You can use, just like you do read and write system calls to read values from a file or write values to a file. Similarly, you can do read and write from the socket also. Okay, so we can have two categories of sockets. One is a stream socket for TCP and datagram sockets for UDP. In the case of UDP, we know datagram sockets means they do not establish a connection, but you have to, okay, we'll come to that later and you'll understand how it is. Okay, then we have the concept of server and client. I think we already discussed what a server is: a software or a process which actually waits for clients to request some service from it. Just we said we have got the example of a web server. Web server is a software or a process which is always running on the server machine, or it can be a simple desktop machine also, but the process is running. Say web server example, you can have Apache web server or Microsoft Internet Information Server. All these are web servers. So that particular process is always running on a particular machine, and it is waiting for clients like browsers to make requests. Okay, that is the concept of the server. And the client is the one who initiates the communication. Client requests a server for some service. If it is a web server, it will be requesting for a web page. If it's a file server, it will be requesting for a file, and so on. Okay. So the client must know, this is important. Client must know the address and port number of the server. Say for example, I am asking, I want to get data from sctca.ac.in. So I must know the address. If I don't know, I might not know the IP address, but I know this ctca.ac.in is called it's called what is known as a domain name. Why we have this is because humans, for human beings, it is difficult to remember IP addresses or numbers. Okay. So domain name or a name is attached to each of these IP address, and there is a system called DNS, domain name service, in the internet, which takes care of the mapping between the domain name like sctca.ac.in to the actual IP address of the machine on which it resides. Okay. So DNS service will take care of that. So basically the client has to know the address and port number. Port number in the case of web server is always 80. It is a standard port number. Okay. So you give sctc.ac.in, that is the browser is requesting the SCT server to send the home page. Okay. So this is a concept of clients and servers. Okay, these are the system calls related to socket programming. When you want to program network programming using sockets, once you understand these system calls, then you can actually program or build any type of client server mechanism. You can build a file server, you can build a time server, or a what else, a web server, or any sort of servers, a client server mechanism can be built once you know all these system calls. Okay, so we'll look at each of them in detail. But socket is the one for creating a socket. We said it is an endpoint and it is uniquely identified by the IP address, the port number, and the protocol which is being used. Bind, that is the next system call. It is actually used at the server side only, and it is attaches a local address to a socket. So we have created a socket and you have to attach it to an address. Okay, for sockets create we only we just create an endpoint, then you have to attach it to a local address, and that is done by bind. So once bind means you're telling the, that is you're telling the underlying software or the software or the networking layers, which is actually all the networking layers are part of the operating system itself. So you're telling the network layers that on this particular IP and port this socket is attached. Okay, and so if any packets come looking for this socket, you have to forward it to it. Now, listen is actually, okay, announces willingness to accept connections. Listening is, it is simply waiting. This also happens only at the server side, listening. That is, the server is listening and it is waiting for connections from the client. Okay. Now, the client side also, we look at that picture later, but client side also you have to, the client actually builds a socket and then it has to initiate a connection. The connection is initiated from the client side and the server has to accept the connection in order for the connection to be established. And once a connection is established, then it is simply send and receive. For just like read and write, you can send and receive to this particular connection. Data, you can send data, whatever data. Okay, it can be a page that we talked about, an HTML page. That will be basically a sequence of bytes, right? That will be placed in the packets and will be sent. And finally, if you want to release the connection, basically socket acts just like it's in case of Linux, all these interfaces acts in a similar way. If whether it is a file or a device or a socket, everything basically it is read and write operations you do on it. Okay. So similarly, when the use for the socket is over, just like in the case of file, you close the file. Here you can close the socket also. Okay, so once you understand these set of system calls, you are ready for building any sort of applications. Okay. Okay, this is in the case of a stream socket or a TCP. what are the sequence of there is basically a set of system calls which have to be called. Okay, so in the server side, first you create a socket, client side also you create a socket, then you have to bind the socket to a particular address, and then you listen on that particular address and port number. Okay, address and port number has to be given here, and then you are saying the server process is listening on that particular, if it is web server, it is listening on say port 80. That is what you say. Okay, so once now the server is all set and ready. Now an action has to be initiated from the client. So the client has to issue a connect system call. So connect system call now it has to give the address and port of the server. Then only the connection can be established. So when the server accepts the request for a connection, now the connection is established. After that, you can have any number of send and receive operations. രണ്ടെണ്ണം മാത്രമല്ല, you can have any number of send and receive operations in order to do whatever operations you want. Once the operations are over, you can do a close. Okay. Okay, this is for a TCP or stream sockets or TCP connection. Now, in the case of UDP, we said it is not connection oriented. You don't establish a connection. Only thing you do is on both sides, the client and server both create a socket and bind to a particular address. Because both sides you have to bind, because since there is no connection established, you have to bind your socket to address and port, only then you get the packets. Okay, then you say send to and receive from operations and finally close. Okay, so in the case of here, in the case of TCP, you have a connection establishment process which happens here, but in the case of UDP, it does not happen. So you just both sides you create a socket and bind to a particular address and wait for packets to come. And based on whatever packets come, you can do packets coming means you are from one side you do send to, and the other side you do receive from. So you get the data, and based on the data, you can do whatever action you want. Okay. So that is in the case of UDP or datagram connections. Now we will look at each of the system calls in detail. Okay, so first is to create a socket, right? That is, this is the system call for that, to create a socket. And in order to use this, you have to include these uh, .h files. And so in order to create a socket, we said we can have either a stream socket or a datagram socket, right? So you have to specify that, as well as what family the socket belongs to. Okay, you can have different actually commonly used is the internet family of protocols, but you can also have Unix family, which has a different set of system calls after the socket is created. It's a different it was earlier used, and it is a different set of protocols for communication, protocols or system calls for communication. So the family we generally use for TCP IP based communication is AFINET, the internet family of what system calls. Okay, so family you have to give is AFINET, and here you can choose the type of socket. You can choose either a stream socket in the case of TCP or datagram socket in the case of UDP, or you can you go for raw sockets, which what raw sockets, what it means is you are actually working on a lower layer than this. Okay, here you are working at, when you talk about TCP and UDP, if you look at the layers of protocols, it actually happens at the transport layer. Raw socket means you are processing raw network packets, and that happens at a lower layer. It is after network layer that transport layer comes, right? So network layer lolla packets are നമ്മൾ process ചെയ്യുന്നത്. We are not talking at the higher level. Okay, that we generally don't do. Maybe we can do, but generally we talk about stream and datagram sockets. Is a lot more simpler to process. And finally, you can give the protocol also. It can be either TCP or UDP. Okay, so in order to create a socket, this is the uh, system call, along with what are the parameters you have to give. And what it returns is, returns an integer. Okay, and it is actually a file descriptor. Just like you read files, when you actually open a file, you get a file descriptor, right? So similarly, when you create a socket also, you get a file descriptor. and later we'll be using this file descriptor in all other system calls. Okay, so the next system call is bind. Bind, what we said is you have to bind we have already created a socket. We have got a file, the file descriptor for it, which we will use as a parameter. So that is our socket. So we have to bind this socket to a particular address. That is what we said. Okay, so the address has to be specified. The IP address has to be specified here. And for that, we have a standard data structure called struct sock address. Okay, so the first parameter is the socket descriptor or the file descriptor associated with it. Then you have to specify the address part of it. Address part, that is IP address along with the, I think the port number also has to be given. Okay, IP address and port number both has to be specified, and that is done in a standard data structure called struct sock address star. Basically, this is a generic data structure which is the same for all families. Earlier we talked about a family, right? AF INET is the family which we will be using. AF Unix means the structure will have a different structure, okay, different organization. But in the case of AF INET family, the structure it looks like this. The name is sock address underscore in. Okay, ഇപ്പൊ നോക്കിക്കഴിഞ്ഞാൽ ഇതാണ് generic structure. It has initially family, and the data part is where you actually give the IP address and port number. In the case of AFINET family, the structure is like this. The first short is the family itself. നമ്മൾ ഇവിടെ പറഞ്ഞ പോലെ തന്നെ ഈ യു ഷോർട്ട് ഫാമിലിയാണ്, ബട്ട് ദ റിമൈനിങ് സ്ട്രക്ചർ വിൽ ബി ഡിഫറെന്റ് ഫോർ ഡിഫറെന്റ് ഫാമിലീസ്. ദാറ്റ് ഇസ് വൈ വി ഹാവ് ഡിഫറെന്റ് സ്ട്രക്ചേഴ്സ്. Okay, so in the case of AFINET family, the next field is a 16-bit port number which you have to specify, and then it is a 32-bit IP address. Okay, that has to be given here, and finally this is unused. Okay, so the internet address itself is a structure which is a long address, long form, long int, unsigned long int ആണ്. That is 32 bits long. Okay, these have to be filled in before we actually call the bind. Okay, and finally this address length is the address of this particular structure. ഇത്രയാണ് നമ്മൾ കൊടുക്കേണ്ടത്. Okay. Okay, this is an example. So before calling bind, you have to fill this particular structure. Sin family is AFINET. Sin port is, say, some port number. You can give 80. But what is this function? H2NS is, it is actually, what do you call, from, now the H2NS and H2NL are, these are functions actually used. Why it is used is since we are working over a network. Okay, if we give a number, just we are writing this code from, say, my laptop or my desktop machine, and I'm using it to communicate with some machine which maybe a server which is placed in the US or wherever it is across the globe, let us say. So we don't know what architecture of the machine it has. Okay, it might be an Intel machine, it might be a PowerPC machine or a Mac, or it can have different architectures, and each of these architectures might look at numbers in a different way. Okay, one might have, you might have come across little endian and big endian format. Little endian means that the sequence of bytes, അതായത് ഒരു 32-bit number ഉണ്ടെങ്കിൽ lowest number might be placed the lowest byte. But in the case of big endian, the order might be different. So that ordering can be different in different machine architectures. And since we are working across machines across the globe, we are actually converting it into a standard format. Okay. So H2NS actually stands for host to network short. Okay. So it is a function which maps a short number to some network, a common standard format. Similarly, so that this is how you set a port number. Port number is 5100, which you convert into a standard network format, and it is assigned to this value. Similarly, your IP address. IP address is you can either give here, you can give 10.0. whatever, or in address any means. This function actually what it does is it is a it's a function, or it is something like a what do you call a macro. Okay, So it gives value of 0.0.0.0. But if you are working with some that is, if you have both client and server residing on the same machine, it is not necessary that you have to specify an exact IP address here. You can work on this itself. Okay, but if you want to actually put a valid IP address, you can give it here as a value, and then you do h2nl and then assign to it. Okay, now once all these are given, then you can call the bind function, bind along with the file descriptor of the socket, followed by the addr port is the actual structure where you have filled in the values, and finally size of the address port is the address length part. Okay, so this is how we uh, call the bind function. Right. Okay. Okay. This is H2NSS host to network short, H2NL host to network long. And similarly, at the other end, from network to short and network to host long, a reverse process also can happen. Okay. In address any is to bind to all interfaces on the machine. Otherwise, you can give it like this. That is, this is the loopback address, but here you can give a valid address like 192.168 dot some 168.0.9. Okay, you give it here, and this inet address function, it will convert this dotted decimal format into actual 32-bit number, which will be assigned to the socket address. So this also can work. Okay. So mostly you can do it this way instead of using in address any. If you're working both client and server on the same machine, then you can use this. Otherwise, if it is on different machines, then you can actually use this format. You can give a valid IP here, and then it will automatically convert into a 32-bit number and assign. Okay. Okay. So what all have we finished? We have created a socket. Okay, we have created a socket. We have talked about bind. Now listen, accept, and after that it will be send and receive, right? So what is listen? Okay, listen function. Now we have set the socket has been bound to a particular IP and port number. Now it has to listen. It has to listen on that port for packets to come. So you just say, you give the sock FD, the file descriptor number. All along we'll be referring to the socket using the file descriptor number. And this backlog parameter is, you can have multiple requests coming in. When you have a server, you might have multiple clients might make a request. So this backlog argument specify how many connections can be queued while server waits for the connection to be accepted. Okay, so when multiple connection comes, you can have it, the OS can actually take the request and have it in a queue. So what is the maximum value of that backlog function? Okay, now it is listening for connections to come, and next when a connection request comes from a client, the server can do an accept. Okay, so accept again. You are referring to the socket using the file descriptor, and here what you give is you need to receive the address of the peer or the client. Okay, that is received in this particular data structure, and the address of it is also taken. Okay. So accept takes the first queued connection request and creates another socket. Okay. So we said that the server is actually listening on a particular port and on a socket, right? So it is waiting or listening for requests from that socket. Now, if you want to have connections, if you want to establish a connection, you create a new socket. The server creates a new socket so that that socket can be connected to the client and further communication happens between them. Okay, so that is what. So the accept takes a first queued connection request and creates another socket with the same properties as the original socket, and then the new socket is returned by the access system call. Now further communication all takes place in the through this new socket. Okay. Now this this particular variable, it returns the address of the client. So again, it is a sock address data structure like we discussed earlier. So it has a capability of storing an IP address and port number, right? So the IP address and port number of the client will come in this particular variable. Okay, once the connection is established, you can simply do send and receive. It is like a read and write in the case of file. So again, file descriptor is given. Now you have to send some data, means you have to place it in a character array called a buffer. Okay, and how many bytes are being sent, how many bytes you are going to send from this buffer is also specified here. And some flags which we will not be using, usually set to 0. This is for signifying signaling whether out of band data is sent or in this particular packet, or you can peek into, that is before coming you can peek into നേരത്തെയുള്ള data നമുക്ക് നോക്കാൻ പറ്റുമോ. All these you will learn when you look at detail in the networks subject. When you talk about TCP/IP protocol, you will know all these in detail, but right now you just need to set it to 0. Okay, so once you have accept, you have a connection established, and then you simply have to send and receive files. And finally, when all the when your use is over, you can use a close function. Now from the client side, we have been talking from the server side. From the client side, again, once the socket is created, then you have to make a request to the server using the connect system code. And once the connection is established, then simply send and receive. Okay. So what is the connect system code? Connect. Okay. Connect system code. Okay. Connect system call again. Okay, connect system call. Again, you are specifying the file descriptor for the socket, and whom do you want to connect. The address of the server has to be filled in this data structure, and the address length also. How do you fill in? Earlier we said, right, you can give the IP and port number, and then you call the connect function, and then it connects to the server. Okay, after the connection is established, then you can say, okay, you can check whether the connection is successful or not using what is returned. It will be a -1 if it is the connection is not established properly. Okay, using that you can check whether the connection has been established or not. And once that is done, you can simply use send and receive. In the case of TCP, you say since the connection is already there, you can use send and receive functions for sending and receiving data. Okay, now now about, so TCP is over. Now we're talking about UDP. In the case of UDP, what we said is we have to create sockets on both ends as well as bind, because both of them, there is no connection establishment. Both of them are simply waiting for packets at random to come in, and based on that, we'll take some action. Okay. So both at both sides, you have to create a socket and do a bind. Once that is done, okay, uh, then you are not initiating a connection establishment. Connection establishment ഇല്ലാത്തത് കൊണ്ട് when you send data, you simply don't send to a particular socket because there is no connection there. Okay, മറ്റേ end ഏതാണെന്നൊന്നും അറിയില്ല. So you use another set of system calls called send to and receive from. And in send to and receive from, the difference from an ordinary send is you have to in each case you have to specify whom you are sending to, the IP address and port number of the to whom you are sending to, as well as from whom you are receiving. Okay, those things have to be specified. We look at that. Okay, send to function is you have to specify the socket. Like in the case of send, you have to specify where the data is placed and how many bytes of data you're going to send. The flags may also be specified again, which is going to be 0 in most cases. And this is the part, sock address. Okay, sock address data structure is for setting your IP address and port number to which you are going to send data. Similarly, here in the receive from part also, similar to this, you have to specify the socket, the bytes, the array where you're going to receive the data, how many number of bytes you're going to receive, and finally, from whom you are going to receive it. Here you don't have any client server concept. Here there are only two machines which are bound to particular addresses, and you can send and receive. That is the concept. Okay. Okay. So here, so once you have this is a basic idea about client, the socket program communication using sockets and socket system calls. Okay, so the first in the cycle of programs, first what you have to do is you have to implement a client server communication using socket program. programming, first using TCP and then using UDP type of sockets. You just have to send some text, അങ്ങോട്ടും ഇങ്ങോട്ടും text just send ചെയ്ത് നോക്കുക, and you have to print it. That is all in this case. In the case of a multi-user chat server, so you have a server which is there. You have to have a server process on one machine and a client process on another machine, or on in the same machine itself you can actually create two processes. So this is your server process. You have a process running here and a client process also. And in the case of a chat server, what happens is this server is waiting for connections from clients. So when a connection is there coming, okay, you establish a connection. So since it's a multi-user chat server, what is expected is maybe you can authenticate the client. So when a client requests and establishes a connection, you can send a message for typing the username. Okay, and then the client types the username and sends it here. Okay, then you have to, maybe you can use a file to check for which are the valid usernames which you have, and based on it that you can validate. And if the username is, and maybe you can ask for a password also. Okay, you can have username, you are asking for a password, the client will send a password to you. You can authenticate using a file നമുക്ക് കുറെ usernames passwords വെച്ചിട്ട് നമുക്ക് വേണമെങ്കിൽ നോക്കാം. And once, if it is properly authenticated, you can say okay, connection established, and the chat session is on. Okay, otherwise you can send a message that is you are not a valid user, something like that you can send. Now once it is validated, then what happens is it is a multi-user chat, right? So one client sends some message that can be transmitted to all clients who are currently online, and it can be displayed at the client side, and you have to say from which user it has come. Okay, similarly that sort of communication, that is what multi-user chat is. അതിനകത്ത് നിങ്ങൾ ചെയ്യേണ്ടത് അതാണ്. Okay, ഇനി next is a concurrent time server. Okay, time server is using UDP ആണ്. ഇവിടെ TCP ആയിരുന്നു, ഇവിടെ UDP വെച്ചിട്ടാണ്. അപ്പോൾ concurrent time server means it is a server which is always running on a machine, and what its role is, that is whenever a request comes from a client, so the client has to send a request in the form of ഒരു string ആയിട്ടായിരിക്കാം, please send me time or time please. So when the concurrent server receives that message, it has to look at the data part. നമ്മൾ send receive എന്ന് പറഞ്ഞ സിസ്റ്റം കോൾസിൽ നമ്മൾ ഡേറ്റ അയക്കാം എന്ന് പറഞ്ഞു, അല്ലെ മേ ബി ഒരു കമാൻഡ് ആണ് അയക്കുന്നത്. ആ കമാൻഡ് വരുമ്പോഴേക്കും the time server can look at the command, and if it is request for time, then it has to look at its own system time. Okay, you can time is actually a command which you can call and get the date. You can use date to get the actual time value. എന്നിട്ട് അതിൽ നിന്ന് you can take the time and send it back to the client. So that is what is other concurrent time server means. It has to take care, that is not one client at a time, it has to handle multiple clients, and that can be done over UDP. Okay, similarly, you have a concurrent file server also. File server എന്ന് പറയുമ്പോൾ again, file server is a server which is running. It has a set of files with it, and maybe you can have an authentication mechanism just like we talked about in the case of a chat server. അത് കഴിഞ്ഞിട്ട് if it is authenticated, then the client can make a request. ഇതെല്ലാം commands നിങ്ങൾ തന്നെ formulate ചെയ്താൽ മതി. That is send file followed by file name. Okay, that is the command which is sent from the client. So when the server can look, file server can actually look at the list of files available with it, okay, in its directory. And then if the files are there, if the file is present, if the requested file is present, then it can send the whole file to the other side. Otherwise, it can say the file is not present. Okay, that is the mechanism which is expected. Now, in the case of a simple mail transfer protocol, okay, SMTP is actually a protocol which is used for relaying emails between mail servers. Okay, relaying message. Email, we are sending an email from the client side to the server. Okay, for that you use what is known as a post office protocol. SMTP എന്ന് പറയുന്നത്, it is actually a protocol which is used for relaying messages. Multiple email servers might be there. From one email server to another, how do you send and receive messages? അപ്പോൾ അതിനുള്ള നിങ്ങൾ സ്റ്റാൻഡേർഡ് ആയിട്ട് SMTP പ്രോട്ടോകോൾ അവൈലബിൾ ആണ്. what happens is initially the mail server which you are trying to contact, the initial request is hello followed by the I can try that is you have two mail servers. From one mail server to another, you want to relay an email message. Okay, so the first command is you send hello followed by the name of the, can be an IP address also, IP address of the next server. Okay, and the response you get is 250. If it is okay, then you get 250. Hello relay.example.org. I'm glad to meet you. Then you send mail from. You're sending an email, right? So who is the mail from that you have to send? And if it is received properly, the other side will send you 250. Okay, who's the recipient that you have to send? So there is a particular sequence of SMTP protocol actually sets out a sequence of messages you have to send, something like this. So this is the sort of mechanism you have to implement. ഈ particular എന്താണ് ഓക്കെ അത് നിങ്ങൾ ഇംപ്ലിമെന്റ് ചെയ്യുക. അപ്പോൾ രണ്ട് SMTP servers തമ്മിലുള്ള കമ്മ്യൂണിക്കേഷൻ ആണ് നിങ്ങൾ സിമുലേറ്റ് ചെയ്ത് കാണിക്കേണ്ടത്. ഓക്കെ, so I think this cycle is okay with this. So any sort of doubts ഉണ്ടെങ്കിൽ you can contact.